Okay, everyone, we're going to get started with Cyber Lab. Thank you all for coming to week 7 Cyber Lab today. So just some announcements as usual. So next Monday, we do have Cyber Academy, same place, same time. But the cool thing is we have a social this weekend. It is a collaboration social with ICPC, and we will be doing a Sawtell run, literally. But of course, if you don't want to run or you can't run, we'll also be having a bus group as well, so everyone can participate. And it'll be this Friday at 6:30 p.m. and we'll meet up at the Bruin Bear. And then we also have the Cyber AI Symposium. So this is week 10, Monday, 6 to 8. We don't have a room yet, but we are getting one super soon. Another thing is there'll be free food. And just a reminder that presenting at the AI Cyber Symposium is a requirement to be considered an active member if you want to use Cyber Lab as your active membership requirement. So make sure to come and show up. And don't worry, we'll also be preparing for the symposium next week. Okay, our last announcement is our E1 course. So I think you all have heard me say this before, but E1 courses, they are easy 2-unit classes. They're just supposed to be chill, fun classes that allow you to explore different topics. So our E1 class will be about creating your own malware. I think that sounds cool. And if you also think that sounds cool, please make sure to sign up for the class. If you're an engineering major, you can sign up directly through my UCLA. If you're not an engineering major, you can't enroll directly in the class. So you'll need to click on the PTE request link and request a PTE for the class. We do hold some PTEs for letters and science students, so we will be able to get some of you in. We can't guarantee all of you. And yeah, now I'll pass it off to Alex for his talk.
All right, so I thought maybe today we could talk a little bit just about how we do infrastructure for LACTF, right? It's a large event, we have lots of people, and yeah, I thought it'd just be a cool thing to look at. So just to make sure we're all on the same page, let's cover what is a CTF, or like what is a Jeopardy style CTF, right? It's just a cybersecurity competition. You hack application or solve some puzzle, right? This could be a vulnerable website. Maybe it's some encryption scheme that's vulnerable. Maybe you're doing some forensics, some log analysis, etc. Ultimately, you get what's called a flag, which is just some string that proves that you solved the challenge. You submit it for points, and you win, right? And generally, people compete in teams, right? You're competing against each other, with top scoring teams getting points. Or sorry, top scoring team gets prizes, not points. And also for LACTF specifically, there are also some other events that go along with the competition, like speakers, tabling, in-person events, though I won't really be talking too much about this. I'll be talking just about the online competition aspect. Are there any questions about like generally what a CTF is? I'm sure most of you probably know what it is, but I just want to make sure we're together. All right, so I'm going to open up to the floor. What infrastructure do you need for CTF? What do we need to host? Like, what applications do we need to do? What do we need to do in the cloud, for example? What do competitors access? Does anyone want to just like raise their hand or just shout it out?
For your CTF.
Website, yes, we need some sort of website for the CTF. So we have lac.tf, which advertises our CTF. But what goes on that website? Somebody else, maybe? Sure. Yes.
Like, you mean the content, like sponsors?
Yep, sponsors are definitely on there. What does the website do, I guess?
You mean like the advertising one, or like
the platform? Yes, there you go. That's what I was going for, right? We have our platform. So do you want to elaborate just a little more about what we want on the platform?
we want like a list of the challenges.
Yep.
That needs to connect properly with like the backend, and then there's like dynamic scoring.
Yep.
I didn't. Yeah.
No, you're on the right track. Just to reiterate, right? We have a platform where teams can sign up, right? See the list of challenges, submit the, whenever they solve a challenge, they submit the flag for points, and we need something to keep track of that as well as, have a really fancy scoreboard. What else? So I have my website that advertises the thing, and I have my scoreboard software. What else do I need?
Challenges. websites.
Yes, a big part of challenges is we also need somewhere to actually run the challenges, because many of these will have or just like a raw TCP application. That's pretty much what I have here, right? We need our scoreboard software, we need challenge hosting, right? Some web apps, some just arbitrary applications, the website, a couple other things you might not think too hardly about, you might not think about at first, but right, we need a support system. We get a lot of questions during the CTF. I want to say we average 200 to 250 tickets every year. So we want a good way to do that. We use Discord tickets. Email would be really annoying. And then lastly, yes, it is. And then lastly, like challenge creation and collaboration. We need a place to like make it easy for people, like challenge authors who might not want to learn about our infrastructure and how to interface with it, how to create and collaborate on challenges so that, you know, a team of just like me and one other person, like me and Jason, and I guess Kias and Katie, can do all the infrastructure without input from the challenge authors. All right, so the scoreboard software, we use our CTF. You've probably seen it from LACTF, kind of looks like this. We also use it for the ACM Cyber platform. This is more like the default styling. And you might also just see this in other CTFs since it's a pretty well-known piece of software. Like, for example, Dice Gang uses it for Dice CTF, which is happening in a month. I don't think I really need to go through this, but I'm sure y'all have seen it. The one thing I will note is that our CTF is very lightweight, which is the primary reason we chose it. It doesn't take a lot of resources. We can run it on a server that's like very, very low CPU, low memory, and it just works perfectly fine. And it supports what I'll call serverless computing. Who here has heard of the term serverless computing? Just raise, like, have ever heard of it? Just raise your hand. All right, a decent number of you. Does anyone want to try explaining what that means?
Just like make the client do everything.
Okay, sort of. Does anyone want to try and give? Yeah, you want to try? Yes, it is in the cloud, but we do still have servers in the cloud. Any last thoughts about what a serverless means? Sure.
So like instead of one central server, your whatever the functionality is running across any time.
Yeah, that's pretty much what serverless is. The idea being, we go up to Google Cloud and we say, here's my application code. I don't want to deal with the low-level details of what the servers are doing. And Google Cloud says, okay. And as more people access the application, right, Google Cloud will automatically scale it up, run hundreds of copies of the platform if it needs to. And then if, you know, everyone stops accessing the website, it'll delete all of them. So we're not charged for resources we're not using. Yeah, just the one thing that it does need to be taken into account is that many copies of the code may be running at the same time. Cloud Run is Google Cloud's version of it, and it's really, really, really nice. I highly recommend you check it out if you ever have like an infrastructure project. All we do is we take our CTF, we turn it into a Docker image, which is like a standardized format for running applications. We upload it to what's called GCP Artifact Registry. We tell Cloud Run, use this image. We point our domain, platform.lac.tf at Cloud Run, and we profit. It just works. It's really, really cool. And like I said, right, we only pay for actual usage. And the cool thing about Cloud Run is if nobody visits the websites, we don't actually pay anything. So during the rest of the year, when nobody's accessing it, or maybe like once every other day, we pay fractions of a cent, if any. And a bonus is Cloud Run does have a free tier that we actually managed to stay under even during LACTF. So we basically don't pay anything. So in the cloud, people love using diagrams. So I have created my own diagram, just very basics. We have our Cloud Run instance running our CTF. It will communicate with a virtual machine that runs a Redis server and database. So this is what actually stores all persistent state, right? Because in Cloud Run, it'll make copies of the code, but it'll also destroy them when nobody's using it. So we need something that's persistent to actually save, you know, teams that are logged in, flag submissions, etc. So we do all of this over here on our virtual machine. And then for competitors to actually access it, we make people go through Cloudflare just to provide some extra protection and caching, just for efficiency and security reasons. Okay, but how do you actually set up the Cloud Run? Kind of cool. This is all set up by Jason if you're curious. We have our platform hosted on GitHub, and whenever you make changes to it, using GitHub Actions, it tells Cloud Build, which is part of GCP, and kind of like GitHub Actions, but you can interface into the rest of Google Cloud to build it, push it to Artifact Registry, and then it tells Cloud Run, you need to update your copy of RCTF, and it will go, and Cloud Run will go ahead and get the new version of RCTF from Artifact repository for future visits. Was that clear? Are there any questions? All right. Oh, yeah. Okay, cool. Moving on. So one last thing, right? RCTF doesn't actually have any administrative backend. Well, it does. It looks like this. This is the entirety of the admin page. It's a giant list of challenges. This is for LACTF, right? Not very easy to work with, right? We don't actually use this. We use what's called RCDS, which you can think of it as, infrastructure as code. Has anybody heard of that term before? Okay, Les, you want to try to explain what it is, or what?
You don't want to.
Okay, that's fair. You can think of infrastructure as code as your infrastructure setup. So all of your computers, like the software that's running on them, we can define it as code, and we'll use some program to take our code and apply it to like a virtual environment and create it. So that what we can do is we can make small changes in our infrastructure as code and run this program, and then it'll just apply those changes for us. And we don't have to do it manually. We're not guessing what's in the system. The code we have written here tells us what's there. I'm going to change it a little bit to say for RCDS, it's challenges as code. I guess I can just show it really quickly here. It'll let me out. Every one of our challenges has a challenge.yaml file, which looks like this. And you'll probably immediately notice some things about it that tell, right? It has the name of the. This is from 2023, by the way. But right, it has the name, author, right? The description. It automatically will put like the URL that you need to access using this fancy templating, the flag, file downloads. And down here, we also can define like the servers that need to run on our like the challenges that needs to be run. So in this case, I actually have 2 web servers and a database, as well as down here at the bottom, how it's accessed. You don't have to like memorize this or anything, but this is actually what's in the backend for every single LACTF challenge. And yeah, for us, it's really nice. We define the challenges in a GitHub repository that's private. And whenever we want to deploy it, we just git clone that repository and we run RCDS deploy. RCDS looks at the code, looks at like our platform, and automatically updates the platform to match the challenges we have in our repository. So just editing our cloud diagram, we have our challenge repository. I then run RCDS, pulling from that repository in something called Cloud Shell, but you could also just do this on your computer. And it will then talk to platform.lac.tf through Cloudflare to Cloud Run to upload and update all of the challenges. Any questions? Cool. So are we done? Oops. Is this everything we need for LACTF?
Yes.
Yeah, we have amazing scoreboard software. You can go submit all the, no, we're missing actually running our challenges, right? We need to run our web server. So far, all that did was just for the scoreboard. So we use Kubernetes. Who has heard of Kubernetes? Raise your hand. Who's ever worked with Kubernetes? Who's heard horror stories or like about Kubernetes being like hard and stuff? Sure. Okay, a lot of you. Yeah, Kubernetes. There's a ton of things that really go into Kubernetes. These are just some icons I pulled from online. This doesn't even have like some of the stuff that we use for LACTF. Don't worry about it. So you can go really in depth into like Kubernetes, their entire jobs, like just managing these Kubernetes. But you can think of Kubernetes as just container or application orchestration, which means it just automatically manages the creation, deletion, and replication of containers across multiple computers or nodes. And it's declarative. We tell Kubernetes, I want you to run one copy of this challenge, and I want to be able to access it at this URL, and Kubernetes does all of the work for us. I don't have to like define firewall rules or network routing or anything. I just tell it, I wanted you to do this, and it just does it. If you're curious, we did a workshop Jason and I did a workshop over the winter break, and you can go to that link to learn a little bit more about the basics of Kubernetes. But for those who did go to the workshop, RCDS does handle the actual configuration of challenges on Kubernetes. So a lot of like the manual file editing that's in that workshop, we don't actually do ourselves. And for the purposes of LACTF, we just tell Kubernetes, I want you to run all of these challenges, and it just runs it. It's so nice. So let's deploy it. We start with our challenge repository. We go through RCDS again. RCDS will build all of the challenges into Docker images and pushes it into artifact registry, essentially waiting for Kubernetes to access later. It then tells Kubernetes using Google Kubernetes, which is Google Kubernetes engine. All right, spin up your nodes, and I need you to run the challenges. So go ahead and fetch those challenges from the artifact registry, and Kubernetes will automatically like decide which node or computer it will run the challenge on and all of this fun stuff, so we don't have to do it ourselves. Are there any questions about this? Cool. All right, so let's talk about ingress. So I guess thanks, I can hide this. Hold on. Let's talk about HTTP ingress. So this is for our web challenges. We just have, let's just say we have a competitor here. It will then go talk to a cloud load balancing. So this is provided by Google Cloud. And you can think of this as like the interface from the external world to inside of the cluster. So anytime you access star.shell.lac.tf, it goes to this cloud load balancer. The load balancer will then filter or forward the traffic to Trafic, which is something we actually control inside of the cluster. And what Trafic will do, it will look at the domain you've accessed and then forward your request onto whatever node is running the challenge that you requested. There's also like cert manager. So Trafic will do like HTTPS just because it's nicer. And we want to make sure we're actually secure in a security competition, but we don't need to talk about that. For challenges that are like TCP challenges, so if you've ever done a challenge, it's like netcat, chow.lac.tf, or ACM box.acmcyber.com in a port. The way it gets into a cluster is slightly different. You actually just contact one of these nodes in the cluster directly on a dedicated port that's in the 30,000 range. It's like 30,000 to 32,700 something. One of those ports, and then this machine will figure out where that challenge is located and forwards the traffic to the node where the challenge is, whether it's on its own node or just on a different computer. Are there any questions? Cool. What if the challenge can't be put in Kubernetes? Well, in my case, last LACTF, I had the DNS challenge, rev slash, that should be 1000 xrev. And this required me to run a custom DNS server, which requires specifically port 53. And Kubernetes doesn't easily support a way to do that. So I just, hosted it on a manually created virtual machine and just set it up by hand. It's only one challenge, not a big deal. Definitely no issues will happen. Well, oops. Midway through the CTF, we get a message. Is anyone else's LACTF down? And then we get another message. LACTF is being blocked by my campus Wi-Fi. And we also get a ticket. I can't access any of the challenges. And, we can access them. We're like, great. What happened? Well, has anybody heard of Palo Alto Networks? Sure, a couple. Has anybody heard of CrowdStrike? Yeah, you can think of Palo Alto Networks as kind of like they do similar things to CrowdStrike. They provide like security solutions for companies to automatically block malware domains. And if you look here, it has taken our domain, platform.lac.tf, and said, it's malicious, I'm going to sinkhole it, which is another way of saying, send all the traffic to us so we can like monitor it and make sure it's not actually reaching us. Great. So anybody who is using a Palo Alto filter network can no longer access LACTF. So not good. We were freaking out a bit. Jason over here actually asked one of his friends and found out, right, it was flagged to DNS, I should say exfiltration, and mentioned, my specific challenge. Turns out Palo Alto Networks automatically determined that this was probably iodine. This is an exfiltration software where, let's say you're a hacker and you're inside some corporate network. And you want to steal company data, but you're not able to like make external like HTTP requests because that would set off some flags. What you might do is instead abuse the DNS protocol in order to send data outside. So you might make a DNS request for like 32 bytes of data.mydomain.com. And your DNS server will see this request and you log it, and you've just exfiltrated 32 bytes of data using DNS. And systems may or may not catch this, but in this case, Palo Alto Networks did. Or as Jason put it, it's official. I took down LACTF infra. You know, you should probably. Anyway, so wait, what happened? Just my DNS challenge made a bunch of requests to this server. Competitors on Palo Alto Networks ran the binary, or they might have just like spammed it on their own. Palo Alto saw this, flagged it, and blocked everything on LACTF, not just the server, which was not great. Resolution, Jason pinged his friend at Palo Alto Networks, and they unblocked it for us. How nice of them. By the way, this is why you should be building a professional network. Yeah, and just to like close out, just a couple other random infrastructure things. Our actual website itself, so lac.tf, is run on Cloudflare pages. It's just a static website, so nothing fancy there. Just with automatic deployment set up from the GitHub repository. The Discord bot, we use Ticket Tool Premium. I just looked for ticket bots and found one that worked. Like I said, we get a lot of tickets, so having a good bot is vital. And then lastly, for like file storage for like challenge downloads, we use Google Cloud Storage in Google Cloud Buckets. Are there any questions or comments?
Well, we pay for ticket pool.
It's like, yeah. I mean, if you want to make your own bot for next year, go for it.
Oh.
Exactly. It's only like $8 though, so it's not a big deal. All right. Hopefully that gave you a little bit of insight onto like all of the infrastructure work that goes on for LACTF. And hopefully you'll see that the infrastructure is, you know, as minimally complex as possible while still allowing us to, you know, have a 1 or 2 person team and do all of the infrastructure ourselves. And yeah, maybe you got a little bit of thought on system design that you could use potentially in interviews. Thank you.
Thank you, Alec, for your amazing talk. Before we go off into our groups, here's the feedback QR code as usual. Okay, and so the Cyber Lab attendance QR code is also up here, and our code word is GCP. So I'll give you a little bit of time to scan the QR code. Okay, it looks like everyone has scanned it. When you're done filling out the form, or while you're filling out the form, we'll get into our lab groups. So as usual, we have root kit up here. We have XSO sanitizer in the back, and then PPML over here in the front.
I guess there's another.